In this video, we'll cover EMF and terminal voltage. EMF stands for electromotive force. So we already know that this is not an actual force, that it's actually a potential difference. A battery is a source of voltage, but also a source of resistance. Each battery has a source of electromotive force and internal resistance. The electromotive force, EMF, is the process that carries charge from a low to high potential or low to high voltage. Terminal voltage is the voltage measured when a voltmeter is across its terminals. If there's no no circuit attached, no current flows, and the measurement will equal the EMF. So again, terminal voltage is the voltage measured when a voltmeter is across its terminals. If there's no circuit attached, no current flows, and the measurement will equal the EMF. We say that the terminal voltage is equal to E minus IR, where E is the potential source in the battery, or the source itself, and IR is the voltage drop on that internal resistance, or that internal resistor. Maximum current will occur when there is zero external current. When solving for equivalent resistance in a circuit, the internal resistance of the battery is considered a series resistor. So the equivalent resistance would equal the internal resistance of the battery plus any resistors that are external to the battery. So now we're finding out that some of the problems we may have are actually coming from the internal resistance of, or not taking the internal resistance of the battery into consideration when solving circuit problems. When the switch in the circuit below is open, the voltmeter reading is referred to as A, EMF, B, current, C, power, D, terminal voltage, E, resistivity. Okay, let's see if you have the correct answer. It should be A, it's the EMF. When the switch in the circuit below is closed, the voltmeter reading is referred to as A, terminal voltage, B, EMF, C, current, D, resistance, E, power. Okay, let's see if you have the correct answer. Hopefully you chose A, terminal voltage. So when it's open, it's called EMF. When the switch is closed and we measure the voltage of the power supply, it's the terminal voltage. A 6-volt battery whose internal resistance of 1.5 ohms is connected in series to a light bulb with a resistance of 6.8 ohms. What is the current in the circuit? Go ahead and pause the video now. Okay, so let's take a look at the solution. First, we draw our picture. And by the way, that is a horrible, horrible picture. Let's do this correctly. They're missing some lines here. It should be like that. So this is your resistor. So just imagine that that's there. Okay, so first we need to find the equivalent resistance. We take the little r plus the capital R1, so this should be little r. Okay, and that's going to be 1.5 ohms, which is little r, plus 6.8 ohms, which is R1, and that gives us 8.3 ohms. We now take Ohm's law. We take the 6 volts, divide it by the 8.3 ohms, and that gives us 0.72 amps. A 6-volt battery whose internal resistance is 1.5 ohms is connected in series to a light bulb with a resistance of 6.8 ohms. What is the terminal voltage of the battery? Go ahead and pause the video. Okay, so let's go ahead and see if you've calculated the terminal voltage. Okay, so here's our messed up circuit again. Again, the net resistance is 8.3 ohms. The current is 0.72 ohms, or I'm sorry, amps. And the terminal velocity is going to be equal to, terminal voltage is going to be equal to IR. I times R1, which gives us 4.9 volts. Okay, so let's go through this again. Here's R1, here's R, this is the battery. Okay, the net resistance is going to be 8.3 ohms. The total current in this circuit here is going to be 0.72 amps. In order to find the voltage for R1, which would be the terminal voltage, it's going to be the current 0.72 times 6.8 ohm resistor R1, not R equivalent, okay, because that would be this right here. Okay, so the voltage that we actually get from here to here, which is what goes across this resistor, not the EMF inside, but the voltage drop we get from here to here is going to be 4.9 volts. A 25 ohm resistor is connected across the terminals of a battery whose internal resistance is 0.6 ohms. What is the EMF of the battery if the current in the circuit is 0.75 amps? Go ahead and pause and see if you can solve this one. Okay, so let's take a look at the solution. Again, we have our power source and our resistor. The EMF, you'll see here, you can use capital E or the funny E. I like the funny E myself. So the EMF is equal to the voltage, the terminal voltage, plus IR, where I is the current in the circuit and R here is the internal resistance. Okay? So the EMF is equal to IR plus I little r. We factor out the I. We know that the current is 0.75 amps times the 25 ohms plus the 0.6 ohms, and that gives us 19.2 volts. So this here is the EMF. Okay, that's inside the battery. This voltage here is the terminal voltage. Okay? In the next video, we'll talk about Kirchhoff's rules.